Hello everyone. In this lecture we'll be seeing about shortest job first scheduling algorithm. In CPU scheduling algorithm we'll be having four types like first come first serve, shortest job first, priority and round robin. The first come first serve scheduling algorithm has been discussed in the previous video. You can refer to FCFS there. In this video we'll be particularly seeing about shortest job first scheduling algorithm. So the thing about SGFS is we will be considering the CPU bus time. So whichever job is shortest, uh, to check whether the job is short or not, or to compare each process job length, we'll be considering the bust time. For example, process 1 bus time is 10 and process 2 bus time is 5. Comparing process 1 and process 2, the shortest job is process 2 because its bus time is 5. So this is how we'll be considering whichever job is shortest. So in SJFS, when a process are there in the queue, whichever process is shortest one, that process will be addressed by the CPU first. So if two or more processes are having same burst time, then you will be applying the FCFS scheduling algorithm there. In SJFS, we'll be having two types. One is primitive, the other one is non-primitive. We'll be seeing both the types here. The first one is non-primitive algorithm. Here, the thing you'll be considering is only about the bus time. No arrival time will be there. In FCFS, we'll be having arrival time. We'll be drawing the Gantt chart according to the arrival time. But in SJFS, you'll be considering only the burst time. So this is the question given, process ID, 4 process has been given and the burst time of each process has been given. So to draw the Gantt chart, as we saw in the previous FCFS video, Gantt chart will be starting from 0. So now the thing you are going to check in SJFS is comparing all these 4 process, whichever process is the shortest one. So here 6873 is the burst time. So 3 is the shortest job. So process 4 is the shortest one. So P4 has been served to the CPU first. So arrived at 0 and the time it occupied inside the CPU is 3. So 0 plus 3, the completion time of P4 is 3. So the next process you are going to schedule to the CPU is the next shortest one. So after 3 P4 is completed now we are going to have P1, P2, P3 which is 6, 8, 7. Comparing this 3, 6 is the shortest job. So P1 will be scheduled after P4. So the time it started is 3, the bus time is 6. So 3 plus 6, the completion time of P1 will be 9. So now P1 is completed, P4 is completed. The remaining processes are P2 and P3, 8 and 7. Comparatively, 7 is the shortest job. So the after P1, P3 will be scheduled to the CPU. So the starting time of P3 is 9. 9 plus bust time 7 is 16. So finally we are left out with one process which is P2. So P2 will be scheduled to the CPU at the unit time of 16. The bus time of P2 is 8. So 16 plus 8, the completion time of P2 is 24. So now we are going to calculate the waiting time for non-primitive algorithm. So the waiting time will be for P1, you can see here P1 has begun at the unit time of 3. So that is the waiting time for P1. So P2 the waiting time is 16, P3 the waiting time is 9 and P4 it begins at the first, so the waiting time is 0. So to calculate the average waiting time, we'll be summing up all the process waiting time divided by total number of process. So this is the average waiting time for the given problem. So the next SJFS scheduling type is primitive algorithm. Here you will be considering burst time as well as arrival time for drawing the Gantt chart. So we'll see how it works. So in the question, process ID will be given, arrival time will be given and bus time will be given. So thing you have to do is first you consider the arrival time for drawing the Gantt chart as it begins with 0. You check which process has been arrived at the 0. So P1 is arrived at the time 0. So start with P1. So now you serve the P1 from 0 to 1, but in our example at the arrival time of 1, P2 has been arrived. as this is a SJFS algorithm, the major thing you are going to consider is whichever process in the queue or at the arrival time is shortest one, those process should be served first by the CPU. So now we are having a process inside the CPU already, and at the arrival time 1 comes, a new process has been requesting the CPU to so now what CPU does means it will be comparing the process inside it and the process that is requesting to come in. So now we are having two processes, which is P1 and P2. 0 to 1, P1 has been served for 1 unit of time. So the burst time 8 has been updated as 7 because 1 unit of time has been served for process 1. At the process unit time 1, another one process P2 comes. So in this point, you are going to compare P1 and P2 already existing and the new process that is coming in. So compare P1 and P2. You check the burst time. Whichever burst time is the smaller, you are going to serve that process. So compare the burst time of P1 and P2 now. So the burst time of P1 is 7 and the burst time of P2 is 4. So we know that 4 is smaller. So P2 is the smaller process now. As P2 is smaller, P2 will be served to the CPU. So now P2 will be continuing from unit time 1 to unit time 2. So at the unit time 2, P3 is arriving. So now this 4 will be updated as 3 because from 1 to 2, P2 has been served for 1 unit of time. So 4 will be changed as 3. Now as at the unit time 2, P3 has been arrived. So P2 and P3 will be compared now. So bus time of P2 and P3 will be compared. Now the bus time of P2 is 3. 3 will be compared to 9. As comparing, it is clear that P2 is a smaller job. So P2 will be continued by the CPU. So from unit time 2 again to unit time 3, P2 will be continued. At the arrival time of 3, P4 arrives. At the unit of 3, P4 arrives. Now you are going to compare P2 and P4. So P2 will be updated as 2 now. The bus time of P2 will be 2 and P4 is 5. Comparing 2 and 5, 2 is a smaller one. So again P2 will be continued by the CPU. So till the completion of bus time of P2, P2 will be continued by the CPU. So from 1 plus the bus time 4 till 5th unit of time, P2 has been served. So before the unit time of unit time 5, two processes arrived, that is P3 and P4. Now after 5, no new upcoming process is there. So before unit time 5, P3 and P4 has been arrived. Now you are going to compare P3 and P4, whichever one is the shortest one, you are going to assign that. So before that, P1 is also there. We completed only 1 unit of time, that is it has become 8 to 7. Remaining bus time for P1 is there. So at the unit time 5, 3 processes are in queue now. They are P1, P3 and P4. Now we are going to compare 7, 9 and 5 bus time. Which one is the shortest one? P4 is the shortest one. Your arrival bus time 5 is the shortest one. So P4 will be assigned now. After completing P4, the bus time is 5. So at that arriving time 5 plus 5 bus time 5, the completion time of P4 will be 10. So the next to P4, we are having two processes. They are P1 and P3. Comparing P1 and P3, P1 is the shortest one, but the bus time is 7. So it will be served next. So at the beginning time 10, the P1 begins and the completion time is 10 plus 7, it is 17. So finally we are left out with P3. So P3 will be served next. 17 plus the bus time of P3 is 9. So the completion time will be 26. So this is how you will be drawing the Gantt chart for primitive SJFS scheduling. Now you are going to calculate the waiting time for all the process. Here the formula of waiting time for primitive algorithm is different. So the formula will be total waiting time minus number of millisecond process executed already minus arrival time. So I'll be explaining this. So here you can see P1 has been splitted into 2 here. Though it is a single process, it has been executed a part before and the remaining part has been executed after some time. So now this is this initial process scheduled process will be called as a number of millisecond process executed already by the CPU. So the formula goes like that. Total waiting time of P1. So P1 is completed. Total waiting time of P1 is the left side of P1. So at the 10 it has been it is the waiting time, total waiting time, minus number of millisecond process executed. So already we are executed P1 here. How many milliseconds we are executed? It is only 1 millisecond. So 10 minus 1 minus arrival time of P1 is 0. So this is how the formula works. I'll repeat again. The total waiting time of P1 is, you see the left side of P1, that is 10, minus how much of time you already executed P1. So this is 0 to 1. For 1 unit of time you already executed P1. So it is 1 minus arrival time of P1 is 0. So the total, the average time of P1 will be 9. For P2, the total waiting time is 1. See the left side unit of time. So it is 1 minus number of milliseconds executed already. P2 has not been splitted. It has executed at one fetch of time. So no already executed phase. So it is 0 minus the arrival time of P2 is 1. So the average the waiting time of P2 will be 0. For P3, the waiting time is 17. The left side you are going to consider. For P3, it is 17 minus it has been not executed before, so it is 0 minus arrival time of P3 is 2. The waiting time of P3 is 15. Similarly, for P4, the waiting time is 5 minus it has been not executed previously, so it is 0 minus the arrival time is 3. So 5 minus 0 5 minus 0 minus 3 is 2 millisecond. To find the average waiting time, you are going to sum up all the process waiting time divided by total number of process. So this is about SJFS primitive, and we also saw about SJFS non-primitive algorithm. The remaining scheduling algorithms will be discussed in the next video. Thank you.